Definition of matrix. Matrix is a rectangular array of numbers, symbol or expression arranged in row and column. It is commonly used in mathematics, computer science, engineering and various other fields to represent and manipulate data mathematical expression. Just you all can see that we have 3 multiply 2 and 2 multiply 3. Next, we are going to talk about type of matrix. As you all can see that we have 6 type of matrix. First, row matrix, square matrix, column matrix, identify matrix, equal matrix, and the last is transpose of matrix. First is a row matrix. Type of matrix that has a single row, but the number of the columns could be more than one. Therefore, if the matrix is in the order bracket 1 multiply n, then it is a row matrix. For example of a row matrix, as you all can see, they have a 1 multiply 3 and 1 multiply 4. Next is a square matrix. A matrix with the same number of rows and columns. An n by n matrix is known as a square matrix of order. Any two square matrices of the same order can be added and multiplied. For example of square matrix, as you all can see that we have 3 times 3, 2 times 2. Next, we are going to talk about column matrix. A matrix with a single column. Suppose a matrix bracket m multiply n, where m represent the number of rows and n represent the number of columns. Example of column matrix, as you all can see that we have 3 multiply 1. Next, we are going to talk about identify matrix. The identify matrix of size n is the bracket n times n square with one of the main diagonal and zeros elsewhere. It has unique properties. For example, when the identify matrix represent a geometry transformation. As you all can see, for the example of identify matrix, there is 2 number only. They only have number 1 and 0. Next is equal matrix. A concept when 2 or more matrices are equal. Matrices are said to be equal if they have the same number of rows, the same number of columns, and their corresponding elements are equal. Example for equal matrix, as you all can see that A equal to E, B equal to F, C equal to G, and D equal to H. Lastly, we are going to talk about transpose of matrix. Interchanging its row into column or column into row. The transpose of the matrix is denoted by using the letter T in the superscript of the given matrix. Example for transpose of matrix is A equal to 2 multiply 3 become AT equal to 3 multiply 2. Operation of matrix. Matrix addition and matrix subtraction. 2 matrix A and B can be added or subtracted only if they have the same order. The sum of 2 matrices of different size is undefined. If you guys can look over there that we have put a picture different of addition and subtraction. Matrix scalar multiplication. To multiply a matrix with a real number, we multiply each element with the number. If you guys can look over there that have a K multiply with A, K multiply with B, K multiply with C, and K multiply with D. So that is we call matrix scalar multiplication. lastly, for operation of matrix is matrix multiplication of matrix. Matrix multiplication involves taking the dot product of row and column, resulting in a new matrix with dimension determined by the size of the original matrix. Is a fundamental operation in linear algebra with specific rules and properties governing its behavior.
Solving system of linear equations. Matrix inversion methods. Determinant 2 by 2. The determinants of a square matrix is a number produced by combining the elements of the matrix in a prescribed way. It is written as determinant A or that A. Determinants 2 by 2. If given A equal bracket A, B, C, D, then determinant A equal A multiply D minus C multiply B. Matrix inversion 2 by 2. 2 by 2 matrix A equal bracket A, B, C, D is determinant A equal AD minus BC. It is simply obtained by cross multiplying the elements starting from top left and then subtracting the product. Inverse matrix, if given A equal bracket A, B, C, D, then A reverse equal A over determinant A multiply bracket D negative B negative C A equal 1 over AD minus CB multiply bracket D negative B negative C A. Determinant 3 by 3. The determinant of a 3 by 3 matrix can be calculated by expanding the top row. Determinant 3 by 3. If given A equal bracket A11, A12, A13, A21, A22, A23, A31, A32, A33, then determinant A equal A11, A12, A13, A21, A22, A23, A31, A32, A33 equal A11 multiply bracket A22, A23, A32, A33 minus A12 multiply bracket A21, A23, A31, A33 plus A13 multiply bracket A21, A22, A31, A32. Matrix inversion 3 by 3. If determinant A not equal 0, then A has an inverse. A inverse given by matrix inverse matrix 3 by 3. A inverse equal A over determinant A adjoint A. Adjoint is the transpose of the matrix of convectors is defined as the adjoint matrix of A and is denoted by adjoint A. Adjoint A equals bracket C11, C12, C13, C21, C22, C23, C31, C32, C33 T transpose equal C11, C21, C31, C12, C22, C32, C13, C23, C33 bracket. Cramer's rule. A useful application of determinant is to the solution of simultaneous equation besides using matrix inversions. Two simultaneous equations 2 by 2 A11x plus A12y equal B1, A21x plus A22y equal B2. Cramer's rule state the following steps to the solution. Step 1. Find the determinants, which means D. D0 equal bracket A11, A12, A21, A22. DS equal bracket B1, A12, B2, A22. DY equal bracket A11, B1, A21, B2. Step 2. X and Y are given by the following ratios of determinants. X equal dx over d0 and y equal dy over d0.
Cramer's rule. 3 simultaneous equations, 3 times 3. A row 1 column 1 x plus A row 1 column 2 y plus A row 1 column 3 z equal B1. Second one, A row 2 column 1 x plus A row 2 column 2 y plus A row 2 column 3 z equal B2. Third one, A row 3 column 1 x plus A row 3 column 2 y plus A row 3 column 3 z equal B3. Cramer's rule states the following steps to the solution. Step 1. Find the determinants. DO equal A row 1 column 1, A row 1 column 2, A row 1 column 3, A row 2 column 1, A row 2 column 2, A row 2 column 3, A row 3 column 1, A row 3 column 2, and A row 3 column 3. That's for DO. DX equal B1, A row 1 column 2, and A row 1 column 3. Second row is B2, A row 2 column 2, and A row 2 column 3. Third row is B3, A row 3 column 2 and A row 3 column 3. That's for DX. DY, A row 1 column 1, B1, A row 1 column 3, A row 2 column 1, B2, A row 2 column 3, A row 3 column 1, B3, A row 3 column 3. That's for DY. DZ equal A row 1 column 1, A row 1 column 2, B1, A row 2 column 1, A row 2 column 2, B2, A row 3 column 1, A row 3 column 2, B3. That's for DZ. Step 2. X, Y, and Z are given by the following ratios of determinants. X equal dx over do, Y equal dy over do, and last Z equal dz over do. Application of matrices in any related field. Matrices have with display application in various fields due to their ability to represent and manipulate data in a structured way. Here are some key areas where matrices play a crucial role. Number 1, computer science and programming. Graphic and image processing. Matrices are extensively used to represent image and manipulate pixels for tasks like scaling, rotation, and transformation. Number 2, physics and engineering. For example, electrical engineering. Matrices are used to solve systems of linear equation, model electrical circuits, and analyze signals. Number 3, economy and finance. For example, input-output analysis. Matrices are used to model the interdependencies between different sectors of an economy. 4. Biology and bioinformatics. For example, genomic matrices are used to represent DNA sequence and analyze biological data such as sequence alignment. 5.
social science, sociology and anthropology. Matrices are used to model social network, analyze relationship and study pattern in human behavior. This example illustrates the versatility for a matrix and their significance in solving complex problems across various disciplines. Question 1. In a system of force, the relationship between two forces F1 and F2 is given by 5F1 plus 3F2 plus 6 equals 0. 3F1 plus 5F2 plus 18 equals 0. Use matrix inversion method to solve for F1 and F2. Matrix inversion method. Solution for question 1. Step 1. Write down the system of linear equation. 5F1 plus 3F2 plus 6 equals 0. 3F1 plus 5F2 plus 18 equals 0. 5F1 plus 3F2 equals negative 6. 3F1 plus 5F2 equals negative 18. Step 2. Write the equation in matrix form. In the bracket 5, 3, 3, 5. Second bracket F1 and F2 equal in the bracket negative 6 and negative 18. Step 3. Find and solve the inverse of matrix. In the bracket F1, F2 equal 1 over determinant A. In the bracket D, negative B, negative C, A. In the bracket E and F. Determinant A equal A times D minus B times C equal 5 times 5 minus 3 times 3 equal 25 minus 9, and the answer is 16. In the bracket F1, F2 equal 1 over 16. In the bracket 5, negative 3, negative 3, 5. In the bracket negative 6 and negative 18. Multiply both sides of the equation. In the bracket F1 and F2 equal 1 over 16. In the bracket 5 times negative 6 plus negative 3 times negative 18. Negative 3 times negative 6 plus 5 times negative 18. Step 4. Add the product of multiplication. In the bracket F1 and F2 equal 1 over 16. In the bracket negative 13 plus 54, 18 plus negative 19. F1 and F2 equal 1 over 16. In the bracket negative 24 and negative 72. 1 over 16 will time with 24 and that will get 1.5 for F1, and second 1 over 16 will time with negative 72 and F2 will get negative 4.5 for the final answer. Question 2. A company produces 3 products A, B and C. Each item of product requires different materials as given below. Product A for steel is 7 units. Product B for steel is 3 units. Product C for steel is 4 units. Product A for plastic is 5 units. Product B for plastic is 2 units. Product C for plastic is 3 units. Product A for glass is 1 unit. Product B for glass is 2 units. Product C for glass is 3 units. The available amount of steel, plastic and glass are 67, 48 and 32 respectively. 1. Show the above information in the form of matrix equation. Number 2. By using Cramer's rule, find how many items of each type can be produced by the company. Answer for question 2, number 1. Form of matrix equation. In the bracket 7, 3, 4, 5, 2, 3, 1, 2 and 3. In the second bracket is A, B and C equal in the bracket 67, 48 and 32. Answer for question 2, number 2. Cramer's rule. Step 1. Write down the system of equation Express the given system of linear equation in metric form. 7a plus 3b plus 4c equal 67. 5a plus 2b plus 3c equal 48. A plus 2b plus 3c equal 32. Step 2. Find the main determinant of the coefficient matrix. Compute the main determinant of the coefficient matrix, which is the determinant of the 3 times 3 matrix obtained by omitting the constant column on the right. D equals 7, 3, 4, 5, 2, 3, 1, 2 and 3. 7 will time with all in the bracket, which is 2 will time with 3 minus 3 times 2. Negative 3 will time with all in the bracket, which is 5 times 3 minus 3 times 1. And the last one is 4 will time with all in the bracket, which is 5 times 2 minus 3 times 1. And the equal 7 times 0 minus 3 times 12 plus 4 times 8 equal 0 minus 36 plus 32. And the answer for D is negative 4. Step 3. Determine the determinant for each variable. Replace the corresponding variable column with the constant column and compute the determinant of 3 times 3 matrices for each variable. Find dA. dA equal 67, 3, 4, 48, 2, 3, 32, 2, 3 equal 67 will time with all in the bracket, which is 2 will time with 3 minus 3 times 2. Negative 3 will time with all in the bracket, which is 48 will time with 3 minus 3 times 32 plus 4 will time with all in the bracket, which is 48 times 2 minus 3 times 32 equal 67 times 0 negative 3 times 48 plus 4 times 32 equal 0 minus 144 plus 128. And answer for the A is negative 16. Next we'll find dB. dB equal 7, 67, 4, 5, 48, 3, 1, 32, 3. 7 will time with all in the bracket, which is 48 will time with 3 minus 3 times 32. Negative 67 will time with all in the bracket, which is 5 times 3 minus 3 times 1 plus 4 will time with all in the bracket, which is 5 times 32 minus 48 times 1 equal 7 times 48 minus 67 times 12 plus 4 times 112 equal 336 minus 804 plus 448. And answer for dB will get negative 20. And now we will find for DC. DC equal 7, 3, 67, 5, 2, 48, 1, 2, 32 equal 7 will time with all in the bracket, which is 2 will time with 32 minus 48 times 2. Negative 3 will time with all in the bracket, which is 5 times 32 minus 48 times 1 plus 67 will time with all in the bracket, which is 5 times 2 minus 2 times 1 equal 7 times negative 32 minus 3 times 112 plus 67 plus, times 8 equal negative 224 minus 336 plus 536, and the final answer for DC we will get negative 24. Step 4. Compute the variable values. The value of each variable can be obtained by dividing the determinant for each variable by the main determinant. First, we will find A. A equal dA over D equal negative 16 over negative 4, and A will get 4. Second, we will find B. B equal dB over D equal negative 20 over negative 4, and B will get 5. And last, we will find C. C equal DC over D equal negative 24 over negative 4, and C we will get 6. Final answer for question 2, number 2. Product A equal 7A plus 4A plus A, and we'll get 13A equal 13A will time with 4, and product A will get 52 unit. Product B equal 3B plus 2B plus 2B equal 7B. Next, we'll get 7 will time with 5, and product B will get 35 unit. Product C equal 4C plus 3C plus 3C, and it will get 10C, and the 10 will time with 6, and the product C will get 60 unit. Summary: we can solve problems using metric equation. This metric method can also be used in everyday life as well. Therefore, the equation created can represent the problem while solving it.